Hello students. So in this video we're gonna start with a an important chapter known as circles. Okay, so we're gonna start with circles. Even in the last academic year, that is in ninth standard, we had this chapter circle, isn't it? So could you define what is a circle? Just think about it. Could you define what is a circle? Maybe not the exact textbook definition, but you have to give me a definition in such a way that okay, you say that the figure circle should come into a mind. Okay, some of you might say, sir, it is a closed figure, isn't it? What is a circle? Circle is a closed figure. Okay, circle is a closed figure. Okay, then can I call this as a circle? It is a closed figure, isn't it? It is a closed figure, but can I call this as a circle? No, this is not a circle. We call it as a triangle. Okay, and then some might say now that circle is a closed figure with no edges or with no sides. Okay, let's take that also. Circle is a closed figure with no edges. Closed figure with no edges. Okay, just observe. Is this a closed figure? Very well, it is a closed figure. Does it have any edges, sides, any sides? No, it doesn't have any sides. Do we call this as a circle? No, it doesn't look like a circle. In fact, in higher classes, you also get to know what type of figure it is. A called of like ellipse. Okay, this is not a circle. This is not a circle. So a closed figure with no edges is not a circle actually. Most of the time, this is the definition that we use. What is a circle? It is a closed figure with no edges. Okay, this is a closed figure with no edges, but this icon, call it as a circle. So what makes a circle a circle? What is the thing, that thing makes a circle a circle? Or I can say what characteristics or what is the most important thing that makes a figure a circle? Okay, the important characteristics, if you have not known, just let's learn it now. It's a very easy one. Circle is a closed figure. Yes, it is a closed figure with no edges. Okay, but along with that, there are two important things known as fixed point and fixed distance. Circle is a plane figure, plane closed figure. Plane in the sense you'll draw it on a board, right? This is a plane. So it's a plane figure. Things that you can draw it on the board, like 2D figures, are known as plane figures. Okay. So in a circle, you got something called as fixed point, or let's fix a point. Okay, and let's take a point and just rotate it. Okay, or let's make this point to move. Okay, I'll take a point, it is fixed. Okay, this is fixed. Let's take another point. Okay, let's make this point to move. Okay, this point has to move in such a way that it is always at a fixed distance. Let's say the distance is some x. Now rotate it, make it to move. Okay, let's say it is coming here, but we have to make sure that the distance again it should be x. Similarly, again it comes here, it comes here, comes here, wherever. Okay, so everywhere, if you measure the distance between this fixed point and the point, the distance should be x. So such a figure is known as circle. So if you connect all these dots, you get a plane figure, and this plane figure is known as circle. So whenever you define a circle, you have to include two important things. One is the fixed point, another one is the fixed distance. So how do I define? So a circle is a plane closed figure with no edges, which has a fixed point, and all other points on the circle are at a fixed distance from this point. Okay, so simple thing. Or you can also give the textbook definition. The locus of a point. Locus is nothing but LOCUS. Locus is nothing but the movement. A point is moving on a plane in such a way that it is always at a fixed distance from a fixed point. Very simple. Okay, locus of a point is nothing but movement. Okay, a point is moving on a plane such that it is always at a fixed distance from a fixed point. As simple as that. And what do we call this fixed distance as? The fixed point, we call it as the center of the circle. This fixed point is called the center of the circle, and the fixed distance is called as the radius of the circle. These things most of you know what. Okay, so we got to know what is a circle, and we got to know what is center and what is radius. Okay, so for your beneficial, let me write the definition also. So circle, okay, the locus of a point. The movement of locus is nothing but movement of a point on a plane such that it is always at a fixed distance. It is always at a fixed distance from a fixed point. Okay, and the fixed point is known as center of the circle. Fixed point is known as the center of the circle, and the fixed distance is known as radius of the circle. Okay, so this is well known. Okay, this, if you give this definition, it will be good. Okay, now in the previous year you had learned certain important terms related to circles, isn't it? Try to recall those. What are the things that you have learned? Very good. You have learned something called as chord, diameter, sector, segment, arc. Very good. These are the things that we have learned. Okay. What are we going to learn this year? This year we're going to learn a very, very important thing known as tangents. Okay. Before getting into what is a tangent, all those stuff, let's recall the terms that we have learned in the previous academic year. Then let's move on to tangents. Okay. Now, you have learned about chord, isn't it? So what is the chord of a circle? And what is the diameter of the circle? And what is the difference between chord and the diameter? Let's understand all those stuff. Now, chord is basically, it is a line segment. I hope you guys know the difference between line and line segment. Segment has got both starting point and ending point, whereas line doesn't have anything. No starting point, no ending point. Keeps going. Okay. Whereas line segment, it has a starting point and ending point. Okay. So chord is a line segment. Okay. It is a line segment. If it is a line segment, then it should have starting point and ending point. Where are the starting point and ending point? On the circumference. On the circumference. This boundary is called as the circumference. Okay. This boundary is known as the circumference. Okay. So take 2 points on the circumference. Let's take it as A and B. Join it. This line segment is called as chord. That's it. This line segment is called as chord. So what is a line? What is a chord? It is a line segment. Okay, joining 2 points. Isn't it? Line segment means it has 2 points. So joining 2 points. Joining 2 points on the circumference of the circle. On the circumference. On the circumference of the circle. Okay. If this is chord, then what is diameter? Then what is diameter? You would have also heard that the diameter is the biggest chord, which means diameter is also a chord. Okay, remember diameter is also a chord. Okay, it is a special chord. Diameter is a special kind of chord. Why? Observe. Let's take a point. Let's say O is the center of the circle. Let's take point P and point Q. Okay, point P and point Q on the circumference. Just observe. I'm joining this point P and Q. While joining, it is passing through the center of the circle. While joining, it is passing through the center of the circle. So basically, this is a chord. I'm joining 2 points on the circumference, so it is a chord, but it is going through the center. Therefore, this is called with a special name known as diameter. So what is diameter? Chord passing through center of the circle. Chord passing through center of the circle. That is known as diameter. Okay, and very well, this is the biggest chord that you can have. Diameter is the biggest chord. Okay, for a circle, how many diameters can we have? How many circles, how many diameters can we have? Think about it. I'll just give you a hint. Let's take a point here and point here. Join it. It's a diameter. This is also diameter. This is also diameter. This is also diameter. Again, this is also a diameter. A diameter, diameter. So like this, we can keep doing it, isn't it? Okay. So therefore, for a circle, we can have infinite diameter, meaning it is beyond finite. Okay. Infinite is like beyond finite. Okay. It is more than finite. Okay. So it has more tangents. Okay. We can draw, we can draw many diameters. Okay. So let's get into the next one, known as the arc of the circle. Let me write it here itself. Arc of the circle. Now, what is arc of a circle? You would have already heard this, right? Now, what is arc? It is simply a small part of the circle. That's it. It is just a part of the circle. It's not the complete circle. It doesn't form a circle. It is just a part of a circle. For example, just observe. This is a circle. But if I erase the small part, the thing that we have got, is this a circle? No. But if I connect this and this, join the dots, you will get a circle. But this is not a circle. This is a part of the circle. This is a part of the circle. This is known as arc. Okay. This is bigger in size. So we call it as major arc. We call it as major arc. Suppose if you take this, let me draw it properly. Suppose if you take only this, forget the top one. If you take only this, which is a small part of the circle again, this is known as minor arc. Okay. So basically what is the arc? It is just a part of a circle. If it is bigger in size, major arc. If it is smaller in size, minor arc. Okay. So what is arc? It is a part of the circle, between any 2 points on the circumference. Between any 2 points on the circumference. Okay. So if it is bigger in size, major arc. If it is smaller in size, minor arc. Okay. Let's get into the next one, known as segment. Very important. What is a segment? It is a region. Okay. It is a place. Where is this place? This place is between a chord and an arc. Okay. Segment is a place. Okay. It is a region. Where is this region? It is between a chord and the arc. Okay. Let's take a circle for example. Okay. Let's take a chord. What do you call the bottom one? This is minor arc. This is chord, isn't it? Between this chord and this arc, there is a small region. This we call it as segment. This is smaller in size, so we call it as minor segment. Similarly, the top one, this is chord. What do you call this as? Bigger in size. This is not the complete circle, just a part of the circle. So we call it as major arc, chord, major arc plus chord gives you major segment. So this is major segment. Okay, the bottom one is minor segment. So what is segment? It is a region between chord and the arc. Okay, very simple. Similarly, there is something called as sector. Okay, what is sector? It is also a region. It is also a place. Now, where is this place? It is between two radii and arc. Okay, let me take a circle. Let me draw two radii. Okay, OA and OB. It's kind of a pizza slice. Okay, in pizza, the slice looks almost like this, right? So this thing, if you observe, you got two radius like this and an arc here, smaller one. So between that there is a small region. What do you call this as? Sector, minor sector. Okay, the other one, if you observe, let me shade it in a different way. The other shaded part is also, you got two radii and an arc. Between that there is a region, that we call it as major sector because it is bigger in size, right? So major sector, this is minor sector. Okay, these are the important things that you have learned, and you would have also learned some other important properties. What are the important properties that we have learned? We'll discuss as the chapter progresses. Okay, so right now we have recalled all these terms. Let's get into the next important concept known as tangents of the circle. Tangent to a circle. Okay, tangents. Okay, so what is tangent to a circle? Tangent is basically a line which meets or which touches the circle at only one point. That's it. It is simply a line which is going to touch the circle at only one point. Okay, that is known as a tangent. Okay, let me draw a circle and show you a tangent. Okay, now if you observe, we have got a circle with center O, and let's take this line as xy. If you observe, this tangent, this line is meeting the circle at only one point. Okay, it is meeting the circle at only one point. So this line we call it as a tangent, and the point where it meets is known as point of contact. So I repeat it. I'm not going to write the definition on the board. It's very simple. What is a tangent? It is just a line. Okay. What is the speciality? It is going to touch the circle at only one place, one point. That is known as a tangent. And the point where it touches is known as point of contact. Simple. Done. Okay. Let me give you another example. Let's take this line to be some M, N. Can I call this as a tangent? You will think, yeah, it is. I mean, you will say, yes, this is a tangent. It is meeting the circle at only one point. No, but this is not a tangent. Why? Because if I produce this line, extend this line, if I extend this line, observe, it is gonna meet somewhere else on the circle, isn't it? If I produce it somewhere, it is gonna meet the circle somewhere, isn't it? Now, how many points does the line meet? It meets 2 points on the circle, one here, one here. Therefore, this is not a tangent. So remember, even if you extend it, it should meet at only one point. So basically this one, even if you extend it, you got only one point of contact, not more than that. So basically this is tangent, this is not a tangent. Some daily life examples that we have seen, think about it. Tangents, definitely you would have seen it, definitely. Okay, think about it. If you want, you can pause the video and think about it, try to answer. Okay, if you've got it, very good. Okay, I'll give you some examples for tangents. Observe the road always acts as a tangent to the wheel of any vehicle, isn't it? So let's say this is the wheel, and let's say this is the road. Have you observed? The wheel makes contact at only one point, isn't it? The wheel makes contact with the road at only one point. So the road is acting as a tangent to the wheel. One example. Or have you seen the sharpening of knife? You got a wheel, a stand. On top of that, you will have a wheel. Okay. If you pedal it, it starts rotating. The person places the knife on the wheel for sharpening. Most probably you have seen it. Okay. The sparks coming out of it. Have you seen it? The sparks coming out of it. Okay. If you think this as a line, this is a circle. Just observe. This line is meeting the circle at only one point, isn't it? It is meeting the circle at only one point. So therefore, this we call it as the sparks are tangent to the wheel. Okay. Another one is during rainy season. Have you observed the vehicle going in front of you? It will what to say? It will eject or put the water outside in a tangent like this. The wheel goes like this. The water comes like this, isn't it? If you got water on the road, okay, during rainy season, as the wheel goes, the water comes like this, isn't it? So if you think this as a line, it is meeting the circle at only one point. So these are some examples for tangents. Okay, so we are going to learn more about tangents, properties of tangents. Okay, and how to draw tangents, that is also there, a very important exercise in the construction. We are going to learn how to draw tangents to a circle. Okay, all those stuff. Now apart from this, there is something called as secant. Okay, there is something called as secant. What is the secant? Secant is a line which meets the circle at 2 points. For example, if I draw this line, okay, if you observe, it is meeting at P and M. This I can call it as secant because it is meeting the circle at 2 points. If it is meeting the circle at 2 points, then I can call it as a secant. Okay. Now let's learn some important properties of tangents. Okay. So there are two important theorems, okay, which are very important from exam point of view for state board students. Okay. So let's learn one by one. Okay. So the first property is, or let's say theorem itself. Let's take it as a theorem itself. So theorem 1 in this chapter. What is the theorem? The tangent drawn to a circle is always perpendicular to the radius at the point of contact. Meaning, suppose you got a circle, okay, with center O, and let's take a tangent like this, xy. Okay. Now, if you draw a radius at the point of contact, this is point of contact P. Let's draw it. This is radius, right? OP is radius. Basically, what is radius? It is a line segment from center to any point on the circle, right? This is radius. So this radius and the tangent will always be perpendicular to each other. Very important result for solving problems. So it's very important. Okay. The angle between the radius and the tangent at the point of contact. Okay. Here the angle is 90 degree. Let's prove this theorem. Okay. So the theorem is the tangent is perpendicular to the radius drawn through point of contact. The tangent is perpendicular. The tangent is perpendicular to the radius drawn through point of contact. This is the theorem, very important theorem and a very easy theorem. Okay, before proving this theorem, we should remember one thing. Okay, that is, You would have learned this in your 9th standard itself in a triangles chapter, inequalities of triangle. Okay, suppose you got a point and a line. There is a point and there is a line. How do you measure the distance between the line and the point? There is a point and the line. Or let's take another case also. You got two lines. How do you measure the distance between them? You got 2 points, easily you can measure, isn't it? Easily you can measure. But you got a point and a line, or between two lines, how do we measure it? So remember, between a line and a point, or between two lines, let it be anything, the smallest distance is considered as the distance between them. And the smallest distance is nothing but the perpendicular distance. If I draw from this point, if I drop a perpendicular on this line, I'm dropping a perpendicular on this line. This perpendicular gives you the distance between the point and the line. Okay, there is a point, there is a line. How do I measure it? Very simple. Draw a perpendicular line. This perpendicular line gives you the distance. And remember, this perpendicular will be the shortest one. Okay, all other, suppose you draw a line like this. This is also distance. This is also distance. But we consider this to be the distance between the point and the line. If I ask you what is the distance between the point and the line, we take this perpendicular distance, not the other one. Compared to all other things, you compare it all other things, this will be the shortest, all other things will be largest. Okay, this can be proved using inequality of triangles. Okay, angle opposite to greater side is greater, or side opposite to greater angle is greater. Okay, so that is the logic. Okay, for that. Now, if you know this, we can easily understand the theorem. Okay. So let's draw the figure. We have got a circle. We have got a circle. Let's consider a tangent xy, and O is the center of the circle. P is the point of contact, isn't it? Let's join O and P. Okay. Now, what is the data? We always start with data, right? So data is what they have given us. They have given that the tangent is, this is the result, perpendicular to the radius is the result. So this is given, tangent is given for what? Circle. So we have got a tangent. So xy is a tangent to the circle. Xy is tangent to the circle. Whenever we write circle, we mention its center. Circle with center O. Xy is a tangent to the circle with center O. Okay. P is the point of contact. If you want, you can write it. Okay. This is the data. Or you can also write it in other words. O is the center of the circle. XY is a tangent drawn at the point P of the circle. You can also write it like that. I've just shortcutted. So what should we prove? We have to prove that both are perpendicular. That is OP is perpendicular to XY. Or in other words, the angle OPY is equal to 90 degrees. That's what we have to prove. Either this or this. Both are one and the same. Okay. The construction, we have already done it in the given thing. We have joined it. Okay. We'll make one more construction. That is, I'm going to take a point Q other than P. You cannot take this point as Q. Okay. It is already given name. The name is given for it, P. Take a point Q. Where am I taking? On the tangent. Okay. Anywhere you wish. Okay. So construction. In the construction, take a point Q on tangent xy other than P, because P is also on the tangent, right? So if I just say take a point on tangent, if I just mention take a point on the tangent, this is already on the tangent. So other than that, I have to take one more point. Okay, take a point Q on the tangent xy other than P. Okay, join O and Q. Okay, join O and Q. While joining, it is meeting the circumference somewhere. So let me take it as R. Okay. Now coming to the proof. The proof is very simple. Okay. Just observe the figure. Very clearly, this OQ is greater than OR. Which is the greater one? OQ or OR? This entire thing was the smaller one. Very clearly, OQ. Clearly, from the figure, clearly from the figure OQ is greater than OR. Clearly OQ is greater than OR. But we know that, but OR can be written as OP. Can you guess? Why is it? Guess it. Simple. OP is radius. OR is also radius. OP is radius. OR is also radius. So take out OR. I can also write OP because radius are same, right? So I can write, which implies OQ is greater than, take out OR and you can write it as OP. Okay. So this equation 1 is true for all the points that you take on this line. You will always get, what I am trying to say is, take any other point. Let's take M over here, very close to P. Let's take N, let's take T. Wherever you take it, you join it, you join it, you join this. Okay. Now this ON will always be greater than OP. This OM will always be greater than OP. See, earlier I had taken point Q. So what did I get? OQ greater than OP. Isn't it? This is the result that I've got. OQ greater than OP. Now instead of Q, if you take some other point, let's say M, then you get OM greater than OP. Same logic. Or you take T, you get OT greater than OP. You are comparing this line, you are comparing this with all other lines. When you compare this with all other lines, this comes to be the shortest always. Observe, OQ is greater than OP, OM is greater than OP, OT is greater than OP. So OP is always the smallest. If this is always the smallest compared to all other things, then this line should be perpendicular to this, isn't it? What did I tell you? This is like a point and this is like a line. The distance between the point and the line is always the shortest distance. Okay. The shortest distance is always the perpendicular line. That is what I told you. This is coming out to be the shortest one. If this is the shortest one, then it has to be a perpendicular one. Because the shortest distance is always a perpendicular distance. Okay, how did I get to know what is the shortest? I compared with all other things. By comparing, I clearly got to know that this is the shortest. I compared this and this. OQ was greater. I compared OP and OM. OM was greater. This is always the shortest. If this is always the shortest, then it has to be a perpendicular line. Okay, so you can write out clearly equation 1 is true for all the points on, it's true for all the points on the line on the tangent xy. Okay, which implies OP is always the shortest, implies OP is always the shortest compared to all others. Okay, if it is the shortest distance, then clearly OP will be perpendicular to xy. Okay, I hope it is very clear. A simple one. We took a point Q other than P, joined it very clearly from the figure. OQ is greater than OR, but OR can be replaced by OP because both are radius of same circle. Okay, so I take out OR, put OP. OQ is greater than OP. This is satisfied for all the points. OM will be greater than OP, OT will be greater than OP, OS will be greater than OP. Take any number of points here. It is always this one, the shortest one. If this is the shortest one, then it has to be a perpendicular line. Okay, so this is the theorem. This is also an important theorem. Okay, might come for the exam. Okay, let's get into the next important theorem, and this theorem is very important. 99.5% it will come for the exam for state board students. Okay, the 0.5% very rarely they can take out this. The next theorem, theorem 2, they can take it out and give you theorem 1. Theorem 1 has not come many times, hasn't come at all, if I'm not wrong. Okay, so there are a slight chance where you might get it. Okay, this is an important theorem. More than this, the next theorem, theorem 2, is a very important theorem. Let's see what is that theorem. Okay, before getting into the theorem, one important thing. Okay, so let's take a circle. Okay, and let's take a let's mention the center of the circle as O. Okay, now let's take a point inside the circle. Let's take a point inside the circle. Okay, now let's play kind of a game. Okay, You have to draw a tangent to the circle. We have to draw a tangent to the circle, and at the same time that tangent should pass through this point. That tangent should pass through this point. Okay, let's try it. Since it is here, let me draw it like this. Okay, seems as if it is a tangent. It has to pass through this, right? Okay, let me take it. But we have already seen, right? This cannot be tangent, because if I extend it, it is gonna meet the other point of the circle. Try it however you wish to try it. You will never get a tangent in such a way that it should be a tangent, at the same time it should pass through a point which is inside the circle. Okay, so you can never draw like that, which means, in another words, if a point is inside the circle, from that point you cannot draw any tangents to the circle. Okay, if a point, take any point inside the circle, from this point can I draw a tangent? No, you cannot draw it, because if you take this to be your tangent, if you extend the other side, it will be meet somewhere. Okay, therefore you can never draw a tangent to a circle from a point which is inside the circle. Okay, now say suppose if a point is on the circle, okay, same task, draw a tangent. You should draw a tangent in such a way that it should be a tangent and should also pass through this point. I can draw it something like this, isn't it? Observe, this is the tangent. At the same time, it is also passing through the given point. Okay, which means, in other words, if the points are on the circle, then you can draw a tangent to the circle. If there is a point, how many tangents can be drawn to this point? Only one tangent. Okay, there is nothing else other than this. You can't draw it. Okay, so if a point is on the circle, one tangent can be drawn. If a point is inside the circle, no tangent can be drawn. If a point is here inside, on, the next one will be outside. If a point is outside the circle, I have to draw a tangent in such a way that it should pass through this point also. Observe, let me draw a tangent like this. See, this is a tangent. At the same time, it is passing through this point. Possible? Yeah. I can also do it the other way at the bottom. Okay. Let's say, let's draw it from here. Okay. Let's draw the other way. I can do it like this. Isn't it? Other than this, is there any other thing that I can do where it should be a tangent, at the same time it should pass through this point? Can I do something? Or I cannot get it like this. If I get it like this, it is meeting here, but it's also going to meet here. So I cannot take this as tangent. Try it out. You cannot have more than two. In other words, that I can say, if there is a point outside, from that point I can draw two tangents to the circle. Very important thing. The next theorem is based on this. Okay, a very important point. If a point is outside the circle, from that point we can draw two tangents to the circle. Okay, if a point is on the circle, only one tangent. If a point is inside the circle, no tangent. Okay, so the next theorem is based on this. What is the theorem? If you observe, from a point outside the circle, I can draw two tangents. Let me name this as A, the point of contact. This is B, point of contact. This length PA and this length PB will be equal. That is the theorem that we are gonna prove. Okay. So let's take down theorem number 2. What is this theorem? It is based on the tangents drawn from external point, isn't it? So let's take the theorem 2. So what is the theorem? The length or the lengths of tangents drawn from where? A point outside the circle, that is known as external point. Drawn from external point are equal. Very, very, very important. 99.5% you're gonna get this for your exams. Okay, so let's take a circle, okay, with center O. So let's take a point which is external point outside the circle. From this I can draw two tangent. One is PA, okay, one is PA, another one is PB, okay. So let's write the data. What is the data? We have got a circle with center O, okay. P is a point outside the circle. What are this PA and PB? Are the tangents, isn't it? So PA and PB are tangents. From where? From external point P. From external point P. These are tangents drawn from P to where? To the circle. To the circle with center O. So what should we prove? We have to prove that these two tangents PA and PB are equal. This is what we have to prove. Let's make small construction, a very easy one. Join OA, OB and OP. A very, very small construction. Join OA, OB and OP. OA and OB and OP. Okay. Now let's get to the proof. If you observe, there are two triangles. One is the upper one, the bottom one, OAP and OBP. In triangle OAP and OBP, I am trying to prove they are congruent. Okay. I'll try to prove they are congruent. Okay. There are 5 postulates, isn't it? SSS, SAS, ASAS, RHS. Okay. If you observe, here the angle is 90 degree. Even here the angle is 90 degree. Why it looks like that? No. Just because it's I've seen students making this mistake. If it is like a L shape, they think it is a 90 degree. Unless and until it is mentioned in the question or given as a hint, you cannot take it. Okay. This is 90 degree. Why is it 90 degree? Because this is radius. OA is radius. PA is tangent. The angle between the tangent and the radius, just now we did it. The angle between the radius and the tangent is always what? 90 degree. So I can tell angle OAP is equal to angle OBP. Both are equal to 90 degrees because tangent is perpendicular to the radius. Okay, along with that, what can I tell? OP equals OP, common side. OP belongs to both the triangles, common side, isn't it? I can also say OA is equal to OB because both are radii. OA equals OB because radii of same circle. Both are equal because both are radii of same circle. Okay. Therefore, the two triangles are congruent. Using which postulate or which theorem? It is using RHS theorem. Why RHS? RHS means right hypotenuse side. Right hypotenuse side means you should have right angle in both the triangles. You have 90 degrees in both. The hypotenuse of both should be same. So the hypotenuse is opposite to 90 degree. Opposite to 90 degrees OP. Again opposite to 90 degrees OP. Both the triangle have got hypotenuse equal and any one side should be equal. OA equals OB. This is RHS theorem. Therefore they are congruent. If they are congruent, if these two triangles are congruent, the remaining parts, that is the corresponding parts of congruent triangles, CPCT. What do I mean by that? It's very simple. If these two triangles are equal, congruent means equal. If these two triangles are equal, that's what we have proved now. Therefore, the remaining parts is PA and PB. Earlier we don't know, right? We didn't know whether they are equal or not. We had to prove they are equal. But we just proved these two triangles are congruent. If they are congruent, then they're identical. Identical means the remaining parts. I've used this in the theorem. I've used this, remaining is PB and PA. Therefore, they have to be equal using CP, CT. This is the last line. Okay, very, very simple. You'll get two triangles. Try to prove it is congruent using RHS. Once you prove it is congruent, you can tell PA equals PB using the CP/CT. At the same time, the angles. Only I just know only these two are equal. What about the other angles? This one and this one will be equal. Similarly, this and this will be equal. CP/CT. Okay, a very, very, very important theorem and a very easy theorem. This will be asked for 3 marks in the exam. Please concentrate on this. So we have discussed what is a tangent and two important properties of tangent. Okay, one is the radius and the tangent are perpendicular to each other. That is, the angle between them is 90 degree. And the other properties, from an outer point, external point, you can draw two tangents. Both the tangents will be equal in length. Okay, these are the important things that we are going to use it for the next class, that is in the next video, to solve problems. Okay, thank you, students.